sums, let us see what are the formulas we are going to use to solve sums from exercise 3.2. So the formulas are listed here. Pause my video and memorize the formulas so that you know which formula can be relevantly used to solve the sum. Let's begin. Hi everyone, welcome back to my channel Learn Math with Priya. In this video, we are going to solve exercise 3.2 sums from the chapter Understanding Quadrilateral. Question number 1, find x in the following figure. So you can see the angle x is nothing but the exterior angle, right? And what is the shape of a polygon? It is a triangle. So any polygon, the sum of measure of exterior angle is going to be 360 degree, isn't it? All exterior angles are going to be 360 degree. So I'm going to add all the exterior angle and I'm going to equate to 360 degree. So what are the exterior angles given here? 125 plus 125 plus x degree is equal to 360. Okay, 125 plus 125 is 250 plus x degree is equal to 360 degree, isn't it? So x is going to be 360 minus 250, which is going to be 110 degree. So x equal to 110 degree. Let's move on to 1b. I need to find the measure of x. So again, this is exterior angle, isn't it? So now you can see there is a small arc given which is in form of a square. So this is 90 degree, isn't it? Here the interior angle is 90. What about this exterior angle? It is also 90, isn't it? At this vertex point, the two angles make a linear pair, right? The interior angle is 90, the exterior angle is also going to be 90 degree. So now add all the exterior angle and equate to 360. Why? Because I know sum of measure of all exterior angle is 360 degree, isn't it? So now I'm going to add all the exterior angle and equating to 360 degree. So 90 plus 90 is 180. 180 plus 60 is 240, 310, right? 240 plus 70 is 310 degree plus x equal to 360. So x is equal to 360 degree minus 310 degree. So the measure of x is going to be 50 degree. So this is your answer. Question number 2. Find the measure of each exterior angle of a regular polygon. So only if it is a regular polygon, I have the formula. Measure of each exterior angle is equal to 360 degree by n, isn't it? So we already know this formula. We are going to substitute the value of n. What is n? N is number of sides, isn't it? So number of sides is already given as for the first question, n is equal to 9. So I'm going to substitute here. So measure of each exterior angle is equal to 360 by 9. So what will be the value? 360 by 9 is going to be 40 degrees. So each exterior angle is going to be 40. If there are 9 sides, 9 into 40 is going to be 360 degree. That is a total exterior angle, isn't it? So this is the answer. The next sum is n is equal to 15. Again, in order to find measure of each exterior angle, we are using the formula 360 by n. So in the place of n, I have to substitute 15. So this is going to be 24 degree, isn't it? So if you cancel, it is going to be 24 degree. So measure of each exterior angle is 24 if the number of sides are 15. Okay, let's move on to the third sum. Question number 3. How many sides does a regular polygon have if the measure of an exterior angle is 24 degree? Again, we are going to use the formula. Measure of each exterior angle. Only for regular polygon, this formula works, right? So measure of each exterior angle is going to be 360 by n. N is the number of sides, isn't it? So if I take this formula, because I need to find the number of sides, so n is equal to 360 degree by measure of each exterior angle. Okay, so what is the measure of each exterior angle which is given in the question? It is 24 degree. So 360 by 24 is going to be 15. Okay, so the number of sides are 15. So this is what you have to conclude. Question number 4. How many sides does a regular polygon have if each of its interior angles is 165 degree? So what is given? Interior, each of interior angle, right? So each interior angle is 165 degree. There are two ways of solving it. I'm going to solve both the methods, okay? Method 1. So what is the formula for finding measure of each interior angle? That is n minus 2 into 180, that is the total interior angle divided by number of sides, will give you the measure of each interior angle. So here I need to find the number of sides, so just keep n as it is. So measure of each interior angle is given as 165, so I'm going to substitute here. So that will become 165 is equal to n minus 2 into 180 degree by n. Take n to the other side, so 165 n is equal to, now you expand the bracket using distributive. So 180 degree n minus 2 into 180 is 360 degree, isn't it? So I'm taking transposing a 180 n to the other side. So it will become negative 180 degree n is equal to negative 360 degree. Yeah. So when I subtract 165 minus 180, it gives me minus 15 degree is equal to minus 360, isn't it? So cancel this negative and negative. So n is equal to 360 degree by 15. So n is equal to 360 degree by 15 degree, which is equal to 24. So the number of sides of a regular polygon is 24. This can be done in other way as I said earlier. So let's do method 2. So for method 2, I am going to find exterior angle of this regular polygon. Okay, if the interior angle is 165 degree, I know interior angle plus exterior angle at any vertex point of a regular polygon is equal to 180. That is, it makes a linear pair. Okay, so I know interior angle which is 165 degree at one vertex point I am talking about. Okay, so plus exterior angle is equal to 180. So exterior angle is going to be 180 minus 165 degree, which is going to be 15 degree. So now this is nothing but measure of each exterior angle because it is one vertex point, right? So measure of each exterior angle, I got it as 15 degree, right? So now in order to find the number of sides, I have the formula which we have seen in the previous sum, 360 degree divided by measure of each exterior angle. Isn't it? Exterior I am just mentioning as EXT. Got it? So now I am going to substitute 360 by 15. So if I cancel it, again I am going to get n is equal to 24. So whichever method you feel easy, you can follow the same. Let's move on to the next sum. Now, question number 5a. Is it possible to have a regular polygon with the measure of each exterior angle as 22 degree? So what is given? Measure of each exterior angle is given, right? And we know the formula to find the number of sides. So what is the formula? Measure of each exterior angle is equal to 360 degree by n. In order to find n, take this to the other side and bring measure of each exterior angle to the denominator, that is cross multiplication, right? So it will be 360 degree by measure of each exterior angle. So now tell me, substitute the value. So when you divide 360 degree by 20, approximately equal to 16. Hence conclude it is not possible to have a regular polygon with measure of each exterior angle as 22 degree. Got it? So let's go to 5b. 5b is a continuity of 5a question. We already have found in 5a if the number of sides is not a whole number, it cannot have a regular polygon with the measure of each exterior angle as 22 degree. Now they are asking, can it be an interior angle then of a regular polygon? If not, why? Okay, so now if I consider measure of each interior angle as 22 degree, so now I have to check whether it can form a regular polygon. Okay, so we already know at any vertex point of a polygon, interior angle plus exterior angle will always makes a linear pair, right? So interior angle plus exterior angle is equal to 180 degree, isn't it? That is linear pair. So interior angle is 22 degree and exterior angle, I don't know, I'm just keeping exterior angle as it is equal to 180. Transpose 22 degree to the other side. So it is going to be 180 degree minus 22 degree, which is going to be 158 degree, isn't it? Now, how we will find the number of sides? Number of sides is equal to 360 by measure of each exterior angle for a regular polygon, right? So, 360 by measure of each exterior angle is going to be 158 degree. So, it is again not going to give me a whole number, isn't it? So, number of sides is not a whole number. Hence, I can conclude it will not be a regular polygon. Hence, I can conclude it is not possible to have a regular polygon with each interior angle measure as 22 degree. Let's move to the last sum of this exercise 3.2. Question number 6. A. What is the minimum interior angle possible for a regular polygon? So consider a least number of sides for a regular polygon. So what is the least number of sides for a regular polygon? Least number of sides are going to be 3. Okay, that is equilateral triangle. So if all angles are equal, then I can call it as polygon, right? Regular polygon. So all angles are equal to x. Let me consider x is equal to sum of interior angle of a triangle will be equal to 180 degree. This is called angle sum property of a triangle. Or using the formula, measure of interior angle is equal to n minus 2 into 180 degree, right? Sum of measure of interior angle. So if the number of sides is 3, then 3 minus 2 into 180 is going to be 1 into 180. That's why sum of interior angle of a triangle is going to be 180 degree, isn't it? So 3x equal to 180. So x equal to 180 by 3, that is equal to 60 degree. So minimum interior angle, okay, is going to be 60 degree for a regular polygon. Now come to question 6b. What is the maximum exterior angle? So I already know interior angle of a polygon plus exterior angle is going to make a linear pair, right? That is 180 degree. So if I already know the minimum interior angle is 60, I can find the maximum exterior angle for this interior angle, isn't it? So exterior angle is equal to 180 minus 60. So that is going to be 120 degree. So the minimum interior angle is 60 degree and maximum exterior angle of a regular polygon is 120. So can we conclude here? So I can conclude the same here. For regular polygon, the least number of sides are 3, which is a equilateral triangle. So minimum interior angle for a regular polygon, which is triangle, is 60 degree, and maximum exterior angle of a regular polygon is 120 degree. So practice well. Let's meet on my next video to solve sums from exercise 3.3. Thank you.